Good day, everyone. Today I'll be discussing a topic that has captured our team's attention, the theory of constraints, or TOC as it is commonly known. Now you might be wondering, why are we interested in TOC? The answer lies in the very essence of our role as industrial engineers. Our core responsibility is to maximize efficiency and optimize complex processes. The TOC provides a structured methodology to do precisely that by enabling us to identify and manage constraints that hinder productivity. Let's consider a metaphor. Imagine a kitchen with multiple chefs, but only one oven. The single oven becomes a bottleneck, slowing down the entire operation. Efficiently managing this constraint can drastically improve the overall capacity of the kitchen, allowing more dishes to be prepared in less time. Similarly, in a production system, identifying and addressing constraints can directly enhance production speed and operational efficiency, leading to better business outcomes. Hence, the theory of constraints is of paramount importance to the field of industrial engineering. Now, let's delve into the process of TOC. It's a 5-step procedure. Firstly, we identify the constraint. In the context of our kitchen analogy, that'd be the single oven. Secondly, we exploit the constraint. We ensure the oven is used optimally, perhaps by scheduling dishes based on cooking speed or importance. The third step is to subordinate everything else into this decision. This means all other processes in the kitchen are adjusted to support the maximum utilization of the oven, prepping dishes in advance, for instance. Fourthly, if the oven remains a limiting factor, we elevate the constraint. This could entail acquiring a larger oven or perhaps adding a second one. Finally, once a constraint has been resolved, we return to step 1 and repeat the process. This could lead us to identify a new constraint. Maybe there's limited counter space for plating, for example. In summary, the theory of constraints is an iterative process that guides us in continually refining and improving our system's performance, aligning perfectly with the principles of industrial engineering. I trust this gives you a comprehensive understanding of why our team values the theory of constraints and how we plan to apply it in our work as industrial engineers.
This course has taught us how to identify and exploit system constraints. Calculating failure rates and uptime helps us to identify the step that is holding back the system's efficiency. Calculating the best locations for buffers is another method we learned. The final was when we found the amount of time that's required for each step during Design Lab 1. The station that took the longest was our system's limiting constraint. We've also learned how to exploit constraints. The usage of buffers is the first method we learned. Adding buffers helps to minimize the impact of a constraint on the overall system. Buffers decrease the amount of wasted time and the impact of line failures when placed in relation to the system's constraints. During Design Lab 1, we balanced our systems by timing how long it takes to do each step. We would then break down or combine steps in order to keep the average station time consistent. This was in order to ensure an even distribution of the workload across all stations.
By applying TOC principle and technique, industrial engineer can effectively optimize process, enhance efficiency, and improve overall system performance. These professionals can streamline operations, minimize bottlenecks, reduce waste, and maximize customer demand. TOC is applicable across diverse industries, including manufacture, logistics, project management, healthcare, and service sector. It is especially valuable in complex systems with interdependency and multiple processes that must meet customer demands. In manufacturing, TOC aids in identifying and optimizing the most significant constraint in the production line, such as a machine or specific operation. In logistics, it helps identify constraints within the supply chain, such as warehousing or transportation, and enables efficiency improvements. TOC is applicable at any stage of an organization's life cycle. It can be used when designing new systems or when optimizing existing processes. It is effective when organizations face challenges in meeting customer demand, experiencing delay, dealing with inventory management issues, or struggling with process bottlenecks. TOC can be applied by industrial engineers, operation managers, process improvements specialists, and other professionals involved in optimizing industrial systems. It requires a multidisciplinary approach involving collaboration between different departments and stakeholders with an organization. The TOC offers numerous benefits that are highly relevant to industrial engineering and industry. It provides a systematic framework for improving efficiency by identifying and addressing constraints, resulting in optimized process and reduced idle time. By focusing effort on the most critical area, TOC increase production output. Effective resource allocation is achieved through prioritize the constraint and providing support. TOC also enhance decision making by consider the impact on the system, leading to more informed choices. Furthermore, TOC promote a culture of continuous improvement by consistently identify and addressing constraints, allowing for ongoing optimization of processes and systems. In summary, the theory of constraint provides a structured approach to optimize operation, increase productivity, and improve overall performance in the industrial engineering.
The theory of constraints can help production lines better meet the demands. By applying TOC principles, organizations can identify and address the constraints that limit the output and efficiency of their production lines, resulting in improved performance and goal achievement. The theory of constraints offers a structured methodology to identify and address the constraints that limit production line performance. It emphasizes identifying the most critical bottlenecks and directing efforts towards them for targeted improvements. By optimizing the utilization of constraints, such as ensuring they are always working on important tasks, the outputs of the production line is increased, eliminating idle time and improving productivity. TOC also emphasizes synchronizing non-constraint processes, aligning activities to minimize disruptions and improving overall flow and efficiency. With a focus on continuous improvement, TOC enables organizations to continually identify and resolve bottlenecks, leading to ongoing enhancements in performance. Additionally, TOC encourages a holistic approach to a system optimization, considering the overall flow of performance of the system, resulting in improved synchronization, communication, and resource allocation. Ultimately, by implementing TOC principles, organizations can enhance efficiency, production output, and their ability to meet production targets.